Good afternoon, everyone. So, in next two classes, this class and the next class, we are going to talk about continuous distribution. Today, mainly we focus on normal distribution. So, this is the first problem which is related to continuous distribution. So, we have given a CDF and we need to do some computation. So, why it is continuous? Because even if you see here, then all the values and what X denote the amount of time a book on 2 hour reserve is actually checked out. So the time is not a discrete value, it's continuous. You can check it out at any point of the time. So first you need to compute probability of X less than equal to 1. So try to see what is given and what it represent. So when we say capital X less than small x, it represent capital F of X, which means it represent F of 1, and X lies between 0 to 2, so it is 1 by 4. Similarly, the next one represent F of 1 minus F of 0.5. You can substitute the values, and the last one can be written as 1 minus probability of X less than equal to 1.5, which is 1 minus F of 1.5. One quick observation is that either you write X less than equal to 1.5 or you write X less than 1.5, both are same, because at the discrete points, or you say that if it is a continuous random variable, then probability of X equal to small x is always 0. In case of discrete it works, but in case of continuous, that's why this equality sign doesn't matter much. So you can verify your answer from here. The same question has few more parts. The next part says that we need to compute the median. Median means those values of x for which f of x is 0.5 or 1 by 2. Now f of x is defined as x square by 4. It should be equal to 0.5, which is 1 by 2, which means x square should be equal to 2, and that gives you x to be plus minus root 2. Now think over that, or does both the values are valid, or you need some so if you see here, then x should be greater than 0 from here, and that's why you should consider x to be root 2. Now density function. In case of discrete, we have already seen how do we use to compute PDF from CDF. Here to compute small f of x, the only way is you differentiate capital F of x. Now if you differentiate when x is less than 0 and x greater than equal to 2, so in these two cases it is 0, and when x is in between 0 to 2, f dash x, so 2x by 4, which is x by 2, and all other cases it is equal to 0. Next part says that compute expectation x and variance x. Now expectation x, in case of discrete we use summation. Here we have to use the integration, so minus infinite to infinite x f of x dx. Now limits are from 0 to 2 only. If you see f of x, it is valid from 0 to 2 only. X, then x by 2 and dx. Now further integration can easily be done by you, and you can verify the answer. In the same way, for the variance x, you need expectation x square, and then you can compute the variance x. If you see part H, then part H talks about expectation of h of x, which is expectation of x square, which has already been computed above. So from there you can get all the answers. So now there comes the questions which are based on normal distribution. So we say that the speed is modeled as normal distribution. If 5% of all vehicles travel less than with this speed and 10% travel with more than this speed, find mean and standard deviation. So x is normal distribution, you need to find the mean, whose notation is mu, and standard deviation, which is sigma. First try to see what has been given. So it is given that if the speed is less than 39.12, then the probability is 0.05, and if speed is greater than 73.24, then your probability would be 0.1, because it's 10% of the vehicle travel with more than this speed. Now if you want to compute mu and sigma, then you have to recall the concept of standard normal distribution. So we say that if x is normal distributed with mu and sigma, which needs to be computed, then z, which is defined as x minus mu by sigma, has standard normal distribution. Now why we need standard normal distribution? Because we have table for standard normal distribution only. So let's transform the information which is given in terms of z. So when we say probability of x less than 39.5, this can be written as x minus mu by sigma is less than 39.5 minus mu by sigma, which is probability of z less than 39.5 minus mu by sigma, and which is equal to 0.05. So this is what has already been given. So notation for CDF for standard normal distribution is phi. So phi of 39.5 minus mu by sigma is equal to 0.05. The next information is probability of x greater than 73.24, which can be written as 1 minus probability of x less than equal to 73.24. And now again you reduce it into standard normal distribution. So this becomes 1 minus phi and 73.24 minus mu by sigma, and this is equal to 0.1, which also means that phi of 73.24 minus mu by sigma is 1 minus 0.1, which is 0.9. So you got these two informations. It means in the table now you need to see that for what values phi of this A is 0.05 and phi of B is 0.9. That gives you linear equations in mu and sigma, and solving them you get the values of mu and sigma. So now see the table, do it by yourself, verify the answer which is here. Okay, so mu comes out to be 58.31 and sigma comes out to be 11.667. What is the probability that a randomly selected vehicle speed is in between? So which means probability 50 less than x less than 65. If you consider the equality also, it doesn't matter, which has already been discussed, which is same as probability of x less than 65 minus probability of x less than 50. Now you need to transform into standard normal distribution. So this becomes phi of 65 minus mu by sigma minus phi of 50 minus mu by sigma. Mu and sigma has already been computed. Substituting the values, you will get these values. So they comes out to be phi of 0.57 and phi of minus 0.71. from the table, get these values and get the required answer. Next question says that if thread length is normally distributed, what is the probability that the thread length is within 1.5 standard deviation of its mean value? So now range has been given within this range. So if you see here, then we have asked that mod x minus mu is less than equal to 1.5 sigma. Okay, because when you talk about within this range, then actually it is talking about, if I take sigma on this side, this becomes mod z is less than equal to 1.5. You can write it as minus 1.5 less than z less than 1.5, or less than equal to can be used, which get transformed into phi of 1.5 minus phi of minus 1.5. So remember all these calculations, how they have been done. The idea is very simple, because when z is in between minus 1.5 and 1.5, so everything outside should not be considered. That's why we have subtracted phi of minus 1.5. And now from the table you can substitute the value. The next part says that farther than 2.5, which means now mod z is greater than 2.5, and we can write it as 1 minus probability of mod z less than equal to 2.5, and use the same approach which has been used. In between 1 and 2, so which means probability of 1 less than equal to mod z is less than equal to 2, which is probability of mod z less than equal to 2 minus mod z less than equal to 1. Now this becomes phi of 2 minus phi of minus 2, and this becomes phi of 1 minus phi of minus 1. Again from the table, get the required values and verify your answer. The next question talks about Chebyshev's inequality, which works for discrete as well as continuous distributions. Now we need to compute these values for different values of k. So probability of mod x minus mu greater than equal to k sigma, this need to be computed. For example, take k equal to 1, take sigma on this side, so this simply becomes probability of mod z greater than equal to 1. If k is 2, it becomes greater than equal to 2. Now we have already seen in previous question how do we solve this one. So this becomes 1 minus phi of 1 minus phi of minus 1, and rest is straightforward. Similarly, you can try for k equal to 2 and 3 and verify the answer. So this is the last question, which says that suppose 75% of all drivers wear a seat belt and random sample of 500 drivers is selected. Now distribution is not given, you need to compute this probability. So which means you need to compute 360 less than x is less than 400, or inclusive and less than equal to. But what is x? So if you spend some time, you will realize that it is actually binomial distribution. So x is binomial distribution with n is equal to 500 and probability equal to 0.75. Now you can of course solve it using binomial distribution, but in that case we may not have the table for such large values. We can approximate it using Poisson distribution, but we can also approximate it using normal distribution. So we say that it is normal distributed with an error of 0.5, and we can approximate when np is greater than equal to 10 and nq is greater than equal to 10. Yes, and if you recall, NP is actually mu for binomial distribution and it is sigma for binomial distribution. Sorry, NPQ is sigma square. So if you verify it, then in that case you will see that NP is 375, NQ is 125. So we can approximate using normal distribution X star, which means with an error. And when we have to approximate it, we will use standard normal distribution. That's why we already computed mu and sigma square. Mu and sigma square would be NP and NPQ as for binomial distribution, because for normal distribution do not know it. So we have to use it for the binomial distribution. If you do all of this, then it turns out to be, as I told you, that 0.5 error. And now you subtract, so on both the side you do minus mu and divided by sigma, and that gives you phi of 2.63 minus phi of minus 1.6. The last part says that fewer than 400, so probability of X less than 400, again you will approximate using normal distribution and get the required answer. So that's all from normal distribution. In the next video, you will see questions related to exponential and gamma function.